To use the natural log rule for integration, we need the pattern u prime over u. To obtain that pattern, we're going to move 2 out of the integrand, constant multiple rule. We obtain 1 over x dx. The solution will be 2 times ln, the absolute value of x plus c. Now, the derivative of ln absolute value of x is equal to 1 over x. The integral of 1 over x dx is equal to ln absolute value of x plus c. Here's a similar case with the do now. We're going to move square root of 3 out of the integrand. We're left with 1 over x dx. And we recognize the pattern, so our solution will be square root of 3 ln absolute value of x plus c. We realize that if u is equal to 4x minus 1, du will be equal to 4 dx. So we need a 4 in the integrand, a 4 dx. We can manipulate to get a 4 by multiplying and dividing by 4. So we will rewrite the integral as 4 dx by multiplying the numerator by 4. And we need to divide by 4. And we're going to, if we multiply by 4, let's say a number and it's 4, we need to also divide by 4. 4 over 4 is equal to 1. So it's 1/4. And our answer will be 1/4. Do not forget 1/4. 1/4 ln the absolute value of 4x minus 1 plus c. Now in some books, the answer will be written as ln the absolute value of 4x minus 1 to the 1/4 plus c because of the log power rule. Ln x squared, for example, is equal to 2 ln x. For b, the derivative of 6x plus 1 is 6. We need to fabricate a 6. We're going to multiply and divide by 6, constant multiple rule. So the answer is 1/6 ln the absolute value of 6x plus 1 plus c, which can also be written as ln the absolute value of 6x plus 1 to the 1/6 plus c. You can find the area using log rule. For this problem, the lower boundary is 0 and the upper boundary is 3. So the area will be the sum from 0 to 3 of f of x, which is x over x squared plus 1 dx. Now, if u is equal to x squared plus 1, du will be equal to 2x dx. Now we have the essential part, we have x dx. We need to fabricate a 2, and we multiply by 2, so we need to divide by 2. So now our answer will be the area is equal to 1/2. Don't forget the constant, 1/2 times ln. We don't need the absolute value because x squared plus 1 is positive. And it varies from, it goes from 0 to 3. It's going to be 1/2 times upper boundary first, ln parenthesis 3 squared plus 1 minus lower boundary ln 0 squared plus 1. So the area is equal to 1/2 times 3 squared plus 1, 10, ln 10 minus 0 plus 1 is just 1, ln 1. Now, ln 1 is really log base e of 1, right? And 1 is e to the 0, so the answer is 0. So it's going to be 1/2 ln 10. Using the calculator, we're going to approximate the value of 1/2 ln 10, and we get approximately 1.51. So the area is approximately 1.51. The next problem deals with pattern recognition. For a, if u is equal to x cubed plus x, du will be equal to 3x squared plus 1 dx, the numerator of the fraction. So applying the log rule, the answer will be ln absolute value of x cubed plus x plus c. If u is equal to 10x, du will be secant squared x dx, exactly the numerator of the integrand. So our answer is ln the absolute value of 10x plus c. Example C, u will be x squared plus 2x, du will be 2x plus 2 parenthesis dx. Factor out 2, du will be 2 times x plus 1 dx, twice the numerator of c. So we need to multiply and divide by 2, and our answer will be half of the natural log of the absolute value of x squared plus 2x plus c, which can be written as ln the absolute value of x squared plus 2x to the 1/2 plus c. If u is equal to 3x plus 2, du is equal to 3 dx. We're going to multiply and divide by 3. Multiply by 3, divide by 3. And the answer is 1/3 ln the absolute value of 3x plus 2 plus c, which can be written as ln the absolute value of 3x plus 2 to the 1/3 plus c.